This video is about rotational moulding. Now, rotational moulding is used in the manufacture of 3D hollow products, so things like footballs, road cones, and even really large storage tanks, anything up to sort of like 3 cubic meters can be made using rotational moulding. You can often detect rotationally moulded products by the fact that they have quite a prominent split line going all the way around the outside the product, and obviously the fact that they are hollow in shape. And it's a similar sort of process that was also, apart from being used for thermoplastic products, also used for things like Easter eggs. Okay, and obviously you can see with the Easter egg you've got that distinguishing line between the two halves of the mould. Now, in terms of stages of the process, there's a few different variants of the rotationally moulded machine, but effectively they all work on the same sort of principle. Now, the one shown in the document there is a carousel model with multiple arms rotating about a central point. The first stage of the process is obviously loading pigment and a precise weight of thermoplastic powder, something like polyethylene for example, into the mould, and then the mould halves are clamped together to form a tight seal. Now, following this, the machine rotates round and moves to a heating element or a heating chamber where the thermoplastic is continually heated to a melting point and continually rotates, normally around 2 different axes. So it's a biaxial machine rotating the plastic round to ensure that the thermoplastic covers all of the mould and does it consistently to give a fairly consistent wall thickness. It will then normally move around to another station where, either by cold air or water sprays, the mould is then cooled down to the point where the plastic becomes solid again and the product can be potentially extracted from the mould. It then, obviously, the mould halves open and the plastic is removed, and at this point, depending on how good quality the mould is, there might be some finishing, as with most moulding processes. Now, what's good about rotational moulding is the fact that you can produce one-piece moulds. It is ideal for both rigid, tough shapes and obviously ones that have a degree of flex, for example a football. A large range of sizes are possible, so you can go all the way down to small medical components or even up to a very, very large storage tank, perhaps for water or sewerage. Surface textures can obviously be applied to the products, so the individual mould halves inside can take on an applied finish or an applied texture, and this will be replicated in the product. The moulds are often also cheaper than if you was producing an injection moulded product, as obviously it's not got that hydraulic ram or force, that pressure that's not forcing itself on the inside of the mould, and therefore these cheaper moulds allow for a smaller production run to be viable, whereas with injection moulding it's generally a much more mass process, because obviously you wouldn't make an economical profit on a product that's only going to be moulded a few times. The only main disadvantage with blow moulding obviously is you can only really produce hollow shapes this way, and if you needed to produce a complicated shape or a complicated 3D shape specifically, you would need to use either blow moulding or injection moulding.